Hello, everybody. I would like to say 2 or 3 words. Yes, I know they are still setting up, and that's precisely why I want to say 2 or 3 words so that we synchronize a little bit and we know who needs to set up and to do the installation. So, hello, everybody. My name is Robert. I guess you were all in the workshop yesterday. Is there somebody who was not there? Okay. So today and tomorrow we will do the hands-on training. So basically the plan is that you all set up the RAN and the core network and operational management, and we show you some use cases and we explain some things about OpenAirInterface, and so that you all get an idea and you then all have something with which you can work afterwards and that you can use further down or maybe just for your information. So, and the idea, first of all, is that today we do a kind of a beginner session. So in the sense of that also those who did not work with OAI and maybe don't know that much about 5G. I mean, I don't know where you come from and what you do. So that just today you have kind of a working system, and tomorrow we go into some more details and also some use cases and so on. And I mean, depending if you're fast, then of course we can start today, but the idea would be to bring everybody on the same state. So, and that's exactly why I already start while people set up there. The first question is, who has Ubuntu installed on their PC? Can you please lift your hand so that I just see? And who does not have Ubuntu installed and, for example, only has a VM or something like this? Okay. In theory, I mean, it's better if we can not, I mean, if we avoid the use of a VM, but in theory, it's also possible. So it's definitely better to not have it, but okay, so we will see this. I will maybe just go around. The second question is, who worked already with OpenAirInterface? Like who started the core network, who started the RAN and so on? Okay, that's not that many people. So this means all the others who did not work with OpenAirInterface. So most, okay, that's okay. So, I mean, and that's the idea, that we get everybody on the same page. So that also means, I assume that most of you didn't download the Docker images, didn't download the RAN and all these kind of things. So the idea will be, as you also saw on the program, that we do this now in like the first hour. That, I mean, first we help you with the setup and we just make sure, so we have some time, but then everybody, for example, downloads some things, and you actually also need a Docker Hub account and so on, which is for free. I mean, no problem here, but that we set all this up. So basically what I would suggest, we go once more around, we let people set up. So what time is it actually? 9:19. So let's say maybe around 9:30 we can start to do that, and we then guide you through the setup. Did I forget something? So I asked about OpenInterface. I have one question. Who knows what Git is? The version control system. Okay, so I mean, we will use this a little bit. For those who don't know, you can search on Google just to get a brief idea, because we will use this a little bit. It's called GIT. Okay. So, I mean, I will go around, see once more who set up their PC and so on, but now I hope you know what we will do. Are there any questions? Okay, thanks. So then enjoy your coffee.
Okay, hello everybody. I think we're starting now with the setup of the OpenAirInterface. Again, I am Stefan, and my colleagues Robert and Jaroslava, we will help you today to set everything up. Just as an intro, it would be interesting, how are we looking like on the Ubuntu things? So who has Ubuntu installed and ready to go now? Okay. Okay, so there is still some troubles. Maybe Robert and Jaroslava can also help you out. So if you don't have Ubuntu at this moment, just please ask them. They will come around and help you in setting that up. Right. Okay. And also, I think Robert already asked the question, but I also want to ask again, who has experience with OpenAirInterface? Okay, yeah, great. So we will just start from the beginning, go through that like step by step, and the goal of is to follow. All right. So let's start. So first of all, what we are going to do here. So first of all, the goal is actually now to install Ubuntu, and it is not really an installation. We will just basically get all the files we need and all the Docker images we need, and that's basically the goal for the next 1.5 hours. So let's start at the beginning. First of all, there is one Git repository. Is everybody familiar with Git, or should I do a small intro with Git? Do a small intro. Okay. So Git is basically a tool, a repository to when you develop software. It's very easy to exchange basically files, and it really helps you with the software development. We are using Git obviously for our code, for source code, but we're also using Git for all our, let's say, files. Like again, the configuration files we need, the image files we need. And Git can be very, very complicated, but actually the basics of Git are very simple. So if you don't, so I suppose you don't have Git, so basically you should open a terminal on your laptop. And basically you can just go with Ubuntu and you type terminal, or you do Control-Alt-T, and then the terminal is open. And then if you don't have Git, you just type this command, and that's sudo apt install git. Yeah, and then you have to type your password. And I obviously already have Git, but for you that should be installing right now. So I will give you some time to install Git. Yeah. If you don't have, like, if it's if you don't follow step, just please tell me, right? Yeah. So basically, what we did here is we installed Git on the command line. So now we are just able to get all the files with one simple command, and that is really the goal. So how does that look like? Everybody has Git, or who does not have Git? Okay. So all right, it looks like people are ready. So yeah, so let's start. That was really the first step to do. So now what we need to do is to get the repository. And the repository is just where all our files are located. Basically, there is this link. We didn't send it per email yet, but maybe you can also just type it. So basically, what we have to do now, you have to open a browser, or actually, no, let's stay in the console. So basically now you make a new directory, and Yaroslav, how are we calling the directory? Okay. All right, I see. Okay, even better. Okay, so basically now we tell Git to get the files we need from the repository. So basically we use one command, and that is git clone. Git clone, and then we need to 1 second. We need to tell where to get the files from, and this is basically the link. So again, I didn't send it per email, unfortunately, because I don't have. You have the emails? Okay, great. So I will just send you this command per email. I think that's the easiest. So you can just copy paste it. And Robert, should I also include the run repository link? Yeah, good. All right, 1 second. I will send you the link soon. So yeah, email is being sent. It takes a while. Yeah. All right. So you should actually have the email right now. As I said, the goal is for now to have this command on your terminal. So I will give you some minutes until everybody has that, because that's really the starting point. Without that, we can't continue, right? So maybe it would be nice if somebody, like, if you have that, you could do a hands up so I know what's happening. Hmm? What do you mean anonymous? It should work. It's a public repository, right? Okay, let's cancel that. That was just. It's asking for a password? Okay, so yeah, all right. So Robert was right. So you need to change the link. It should not be git add. It should be https:// like this one. Maybe I will just also. Can you read it? Should I make it larger? It's okay. I apologize. I made a mistake. I copied the wrong link. That was for later. That was for the. I will clear that. Sorry for that. It is this link. If you already cloned the other one, that is great because we need it anyway for later. But what I gave you here was the run repository. So sorry for that. I will also send this command per email. Okay, so as far as I've seen, more or less everybody's ready except the networking issues and some Ubuntu things. So basically, I think you already did that. Now I have to clone the repository. So I have it now. And yeah, so basically, now you can just go into the repository. You can change the directory with OAI workshops. So you're now inside the directory. Yeah, and now you basically you have all the files that are required for setting everything up. What we have to do now is to yeah, maybe because we have all does that work? No, it doesn't. Okay. Anyway, so if you don't have, okay, that's no. Maybe you can now also, because it's nicer in the browser. We could do everything in the console, but it's because I would like to go through the README with you, and it's better to be in the browser. So basically, you can just copy this link here, the one we used for the clone, for the Git, and you just open it in browser, for example, Firefox, and then that should work. So you should see something like this. So I will try to zoom in here. Can you read that also in the back? Is it? Yeah. Great. Okay. Yeah. So basically, we are now here, and I'm just showing this in the browser because these files we also have now on our local computer, but I opened it in the browser so that we have a nice, nice GUI for that. So basically, that's the first step we did. We already cloned this repository. That's the first step. Here is the hardware requirements. I think we're set for that, and also the software. So now, actually, we should install the software that is needed to run everything. So basically, what we will be needing for it is Wireshark, and Wireshark is a tool to capture packets, to see what is happening in the network, and actually also to debug a bit and see what is exchanged between network functions and so on. So if you're all on that page, you can just copy these commands, copy paste in the terminal, and actually install this software. So you should install with these commands, install Wireshark, and then with these commands, install Docker. And Docker is used, then it is a containerization software, and we use that to run all our network functions. So if you can just follow these steps here and install all the requirements, that would be great. Just copy paste them. It's very easy. And again, better open it in your browser so you don't have to type it. You can just copy paste it. You can have some nice button here. And yeah. Won't work. Just a general comment. So if you copied everything and you copied it to your console, please make sure to do this last command. Just copy this line, because if you copied everything, it did everything until here, and here it didn't continue. So just do this command as well. It will help us later because then you don't need to do. Yeah. And if you're done with that, you can log out of your user and log in again. Just go here, log out, and then log in again. Okay, again, two common things. When you install Wireshark, it will ask you if you want to add your user to the Wireshark group. Here, just say yes. It is easier because then you can run Wireshark without root. And if you install Docker, you can log in and log out. Sorry, log out and then log in. Or you can just type this command a new GRP Docker, so you don't have to log out and log in again. And I mean, you don't even need to reboot, just log out, log in. But then they're losing the link. Can we go to the next step? So basically, what should work now, if you type this command, docker ps, you should see this. So if everybody could just quickly try that and confirm that it works, it would be great. All right, so now we are ready. Now the goal is to create an account on Docker Hub. Like as I said, I explained before to some people, it is in theory not necessary to have an account because you can just pull all the images. But in our setup, it's better to have an account because Docker has a rate limiting, and if you all pull the images with the same IP address, there might be a problem. So anyway, we just need to create an account, and it's very simple. You just go to this page, basically docker.com. I think Robert already told some people. And I think you click on get started, no? You click on sign in. No. It's a problem because I already have an account. Sign up. So if you go here, you just sign up, you create an account, put your email, username, password, whatever, and then just sign up. I think you will need to confirm your email address or something like that. Yeah, just create your account. I will give you some minutes, and then if everybody has an account, we will do the next steps. And for those who are a bit faster, basically what we need to do is to create a access token on the Docker Hub. So you can also do that, but I will go through that process anyway. All right, so I think now everybody should have a Docker Hub account. Who doesn't? All right, it looks good. Okay, so basically what we have to do now is we have to log in with Docker, and basically just to tell Docker your credentials, and then actually we are pulling all the images for the OAI core network and also for the radio part. So we're doing that. That will take some time because we have to download everything. So we'll just go through that, and then we will have, I think, a short break during download. It's like 10 minutes it's taking. So I will go through all the steps. So basically within the folder you just type docker login, you type your username, DHB in my case, and then you just type your password. And yeah, you ignore this warning for today. And then you should see something like login succeeded. Yeah, so that's it. That's basically very easy. And now you can see in the training, we have basically finished our preparation. So we have everything what we need to now really go into the installation of the core network. So if you're going back to the browser to where the tutorial is, you can just click on core network hands-on tutorial. You will get the information here. I will later go through a bit about the architecture, but we're still in the preparing phase. So basically what we can do now is to actually create the environment. We already did that. We have Docker Compose. That's a bit, oh no, do we have Docker Compose? Yes. Ja, it should be. Ja, ich habe es schon installiert. Yeah, so if everybody could just check if this command works, docker space compose, because we will need it very soon. So that should work if you downloaded the last version of Docker. Alternatively, it could also be docker dash compose. I think it really depends on your version. Yeah. So docker compose, or actually docker compose. Yeah. All right. If you have that, we can just now download the images. Basically going through. Yes. Let's try that. Let's try that. So basically, we're now going to the core network repository. It's just called CN. And we can see which kind of files are here. But basically now we just have to type one command, and that is docker compose pull. And with this command, we will just download all the images. You can see that, and now it is working. So now it is downloading all the images. So just please do that step. I will put it here. Just do that step and we can download everything. So yeah, again, that should take some minutes. So yeah. So if that command was successful, you can also do the next two commands. So you can also pull the OAI NRUE and the OAI GNOP. Okay, just a general thing, because there was a question, what is the difference between what we're doing here, Docker Compose pull, and what we're doing here, Docker pull. So basically, I will later go through the Docker Compose file, but the Docker Compose file gives us, yeah, it's like a setup, which kind of Docker images we are using. And if you're just saying Docker Compose pull, it is a shortcut. And then Docker Compose will download all the images that are used within this Docker Compose file. And Docker pull is just directly. When we say Docker pull, we need to give the name of the image. And the name of the image is that. And that is basically the difference. So we've seen here, we downloaded OAI, NRF, UDR, AMF, all these components. We could have also done it manually, Docker pull, OAI, NRF, Docker pull, OAI, SNF. So it's basically a shortcut for that. Yeah. Also, Docker Compose is quite nice. Even if you don't pull it and you just say Docker Compose up, which we will be doing later, it will also download images for you. Yeah. So yeah, one comment that's also in the tutorial, and I think we should also do that. If you did the Docker Compose pull, just also pull these two images. One is the OAI NRUE, and one is the OAI GNOP. So it would be good to also pull them so we are ready for the whole session. Yeah, I think we can do a break. Yeah, let's make it like that, because I think now everybody is busy with downloading and installing and everything. So let's make a break now, because basically, if we have the installation ready, we are ready for the core network part. So I think the first part is more or less done. Let's make a break of, I don't know, 15 minutes. And for those who are not yet ready, you can just run, you can pull the images, and the goal is like at the end of the break that everybody has their setup ready. Great, thank you. All right. Okay, Robert is explaining something. I would then soon continue with the workshop, and also would like to give you an overview what we did until so far. So I would like to take 5 to 10 minutes, I'll wrap up what we did and where we're standing right now. And then we have like 45 minutes to do a first deep dive into the core network, just show you how to launch everything, how it looks like. And then actually in the afternoon, we will also do some joint work already with core network and RAN. So it's a bit different than on the agenda, just very brief. So then actually tomorrow we can also do a more deep dive into core network and RAN. So today we will mix up the program a bit. All right. So that being said, I would just like, I'm using our tutorial on the Git repository to go through what we did so far. Just a wrap up. So we started here. Again, this is everything hosted on GitLab, and GitLab is where all the code is. And for our case, we have this repository for the workshops. And here we don't have code of the network functions, but we have all the files we need to run everything. So we have the Docker Compose files. We have these tutorial files, like this text here is also part of it. So everything you see here is now also locally on your computer because we did this git clone command in the beginning. I just open it on the browser because it is easier to see because the browser actually shows that nicely. But for example, you could also, if like now I'm again in my local computer in the console, cut is a command to just read the content of a file. So you can actually see here, if you do cut readme, you can see it is the same as we have in the browser. It's just nicer there. So basically, we downloaded that, so that's great. Then we installed all the requirements. That is just a very basic Linux install. We installed Wireshark. We also installed, sorry? Thank you, Robert. Robert is asking all the hard questions. So Wireshark is actually a tool to trace all the packets on your computer. So basically you can see what is happening in your network. We will later open Wireshark. So you see the packets which are exchanged between different components, different hosts, different images and containers. I will explain all these terms soon. So yeah, it's just basically you can see what is happening in your network. Basically, I can just launch it now. It doesn't matter what we see here. That's how it looks like. You see the packets exchanged in your computer. So, all right, that's Wireshark. Then we installed Docker, and Docker is actually this tool we are using to launch everything. We are using Docker to launch the core network, and we're using Docker to launch also the radio part, the run part, at least in the core network tutorial. So Docker is an engine that allows us to run containers. And a container is like a lightweight virtual machine. It is running on this computer, but it has its own operating system and its own code and its own programs running in the container. So what we did in the OpenAirInterface, for example, if there is one core network component like the SMF, for example, we pack that in an image, in a Docker image, and then you run it from this image as a container. And that is basically what we did so far. Like not the running, but what we downloaded all these images. So what you have now on your PC, on your local PCs, is actually everything you need to run the core network and everything you need to run the run within Docker with the RF simulator. Yes. So that's it. And yeah, we installed Docker. And with this command, you can see here, no, sorry, we skipped this one. With this command, with the Docker Compose pull, we got all these images. And again, the Docker login is actually optional, but we did it here because Docker doesn't like it when many requests are coming from the same IP address, because we are all in the same network. It is better to log in because otherwise there could be a rate limiting. That's the reason why we did it. But all the OAI images are public and you can just download them without logging into Docker. But anyway, it's recommended to just do it, but in theory it's optional. So, and again, as I said, with this Docker Compose pull, we will very shortly, like now we will go into the Docker Compose file. With the Docker Compose pull, you tell Docker, download all the images we need, which are defined in this file. Yeah, and then also we manually, so to say, pulled 2 images, and one is the OAI NR-UE, so the actually UE, like the smartphone, and one is the OAI G0B, so the RAN. Yes. And that's basically what we did. Robert, did I forget something? Right? Okay, he's happy. Are you happy? If you have questions, just please ask. Like, I'm happy to answer that.
So for the NR-UE, full implementation of the
Yes, I mean, it's the entire implementation of a UE. And Robert, correct me if I'm wrong, you could even use that UE with an SDR and actually use it with a real radio. Is that correct? Yeah. Now is the RAN expert explaining that?
I don't want to say that much, but basically the core network is the entire core network that we downloaded, and the GNOD B and the UE is also the full network stack that you would use when you have, for example, radio deployment. So I have a radio deployment I can show you later during the lunch break. But what we will do now, we will basically run the GNOD B and the UE locally only on your machine. And instead of using an antenna and like sending signals and so on, the GNOD B and the UE, they will exchange the information directly in the PC. And what I want to say basically is that by pulling those images, you basically have the full GNOD B and the full UE. You could use a radio, but this would be complicated here with interference and so on. So we will just do it locally, but it's the full UE and the full GNOD B, the entire stack. So for those who know terms, the entire from the physical layer up to RRC, everything is in these images, okay?
Thank you, Robert. Okay, any more questions? No. Great. So, okay, so I will take the next 45 minutes to go through the core network tutorial. So I will start with a quick introduction about the architecture, how it looks like, and then we will do a hands-on, start it, look what is happening, and then we will actually also connect the GNOD B and the UE, what Robert said. But again, it's locally on the machine. Basically, the setup we are doing now live here, he has with the radios. Yeah. All right. Cool. So we don't need this step 5, so we skip it and we just go directly to the step 2, chapter 2. And yeah, basically this is just an example. This is just an explanation how we can configure all these files. And actually, before going to that, I will just show you the architecture of the core network, as I said. So this is how the core network we are using today looks like. So basically we have all the components in the core network. We have the SMF, we have the AMF, the authentication function, UDM, so all these components. But basically what is important here for this okay, let me ask a question. Like, how familiar are you with the architecture of core networks? Okay, one thumbs up, the other. Yeah, so, okay, I will just quickly go through very, very briefly, give an overview of what the components are doing, because there is many components in the core network, but some are very important and some just have a support role. So basically from the architecture, if you look at a 5G network, I mean, maybe it is easier to start from the GNOD B. So the GNOD B is the base station. And so that's what's in the back here. And we have the UEs, so the smartphones, whatever kind of modems to connect there. So that's the user side, user-facing side. But then in the background, we have the core network, and the core network is responsible for IP address management, for session management, for registration, authentication. So for example, the key you have on your SIM code, all this authentication, it's all done in the core network. And when you look at how these interact, basically you have the RAN, the GNOD B, and we will have later a deep dive into that. So I will skip that a bit. And this one communicates with the AMF. The AMF is the access and mobility management function, and it does access and mobility management. So it handles the state of the UE. Is it in idle mode? Is it active? Is it connected? So the AMF is responsible for that. And so the AMF is also kind of user facing or facing to the UE, to the user equipment. But then within the core network, we have many components who exchange a lot of information with each other. And we will see that later live with a Wireshark trace. And most importantly here is the SMF. The SMF is the session management function. And yeah, surprise, it does session management. So basically the SMF is responsible for establishing a PDU, which is a packet data unit. It's a complicated term, but basically setting up your data connection. So first you register your device, you're connected to the network, and then you you get your data connection. So basically, if you do airplane mode on your phone and then disable the airplane mode, what the AMF is handling is the first step. So it says you're connected to the mobile network, and then SMF is then responsible for you actually having a 5G symbol there, because that means you have a data connection. So there's a bit of split between these two. Yeah, and SMF is responsible for IP address management. So what kind of IP address your client gets, your DNS settings, and all these kind of things. And also very important is slicing here, and like your DNS, like all these kind of configurations are important for SMF. But let's not go into the details now. And then you also have UPF, and the UPF is the user plane function. And basically, the user plane function is responsible for the user plane, because that is maybe a very important concept in the 5G core network, is that we separate the control part. So the messages we need for session handling, for registration, for deregistration, they are split from the actual user traffic. So when you turn on and off your device, you have the control plane, connecting, authentication, and so on. But then when you go to the internet, open your browser, that's another kind of traffic. And that is the user plane. So we have one component only handling that. Robert? No? Okay. No comments from your side. Yeah, he's making a phone. So don't look too confused. Or actually you do, whatever. So yeah, so that is the UPF, just responsible for handling. Honestly, the UPF is a very fancy router. So it's not much different from a normal router. It just has some additional capabilities. But in itself, the UPF is quite dumb. It doesn't have much functions. That being said, is the most difficult part to implement, because we have a lot of performance real-time issues. But yeah, so these three are the most important components in the core network. And actually, we have a setup where only these three can already run the core network in this mini setup. But we're not doing that today because that's a bit too many. So we also have other components. I really won't go into details, but the UDM is basically user data management. It gives you all the user data. And the UDR is a database. It is really just a database with interfaces. And the authentication server function does only authentication. So they have a very clear purpose, and they are very easy components. And the NRF is the network repository function. That's basically a DNS server. Again, a very fancy DNS server, like a name resolution server. So for the components to interact. And that's the core network. And then in the OAI core network, of course, you know, we have to use a database to store user traffic, and we're using MySQL for that. Yeah, and we have another component in the Docker Compose file, which I will show you in a second, and that is called OAI XDN, or I'm not sure if this one, maybe we also, I will see, maybe they're also called traffic generator, and that is basically just to have an end-to-end connection between the device and the internet. So for our purposes, this host here is the internet. Yeah. Right. Yes.
If you don't want to answer one, then I will answer.
Well,
I mean, there are stupid questions, but I want to say out there basic questions. If you, I mean, I don't know, we don't know whether you know about 5G networks in detail or how much you know. So if you have some questions, then maybe ask them. And there are no stupid questions.
I just want to ask on the database aspect, because you said you are currently using MySQL. I just want to know, I haven't checked the code base, but how easy is it to configure like a different database instead of MySQL, let's say Postgres or MongoDB, and host it separately?
I like the question. Actually, to change it, for example, to Postgres or something like that, is you have to change the code, because we are fixing it to the MySQL dialect. But actually, we have integrated MongoDB. So with the configuration, you can actually change it to MongoDB, which is really cool. Yeah.
Okay, so I'll assume, given that let's say for example, currently you are undergoing the Docker implementation of the Docker deployment, so the database would be part of the image or containers that will spin up. But is it possible to instead of hosting it within this, let's say, same machine, same Docker, but host it like separately?
Yeah.
Would that be possible for the code base as well?
Sure. That's supported now. So if you want, like, I don't want to go into the details for you, but for example, if you want to have, you have a cluster of MongoDB and you have your shards and you have your replica sets and you have your user database there, like really professional setup. You can just use that and it's running on your, so that works. Yeah. And we have, not here, but also later I will show you, we have another repository where we have many tutorials. So there we actually have a Docker Compose file for MongoDB, if you're interested in that.
Just one last question.
Sure.
I just want to ask on the aspect of backing up, or I don't know if you want to call it mechanics, but backing up of the main database. Let's say you are hosting it on Docker. Are you guys already have you guys already implemented that, or will it be upon us to go ahead and work and do like an implementation, everything the database for security purposes or safety purposes for data?
So I would recommend that you use the features of MySQL or MongoDB so that you don't implement the replica in the code of the OAI components, but in the database where it belongs. So that works already. And for the Docker, I think if you do a persistent volume and you mount the volume, that should be enough. But again, as I said, the deployment options, you could even have bare metal MySQL server somewhere with your replica sets, with your RAID or whatever. So that's not something you have to implement in code, but that's just something you have to configure. Yeah. There was another question in the back, there in the back. Yeah.
So maybe you can answer this later as well if you want, but there's quite a, I would help me if you can just maybe show where the IP addresses that are in the containers, where they attach. I see there's one there when I look closely. They're all on the same subnet.
Yeah.
And then the UE serve addresses, but there's tunnel addresses as well. So maybe just touch on that. How that works together.
Yeah, that's a good question. It's a bit advanced. Maybe I will go through that when we do the live demo. Yeah.
When a user tries to send data into what are the sequences of the data function from the access management all the way to the case?
Yeah, that's a good one. Basically, you have the core network running, and we will all do that live now. You start the core network, they exchange some messages within each other, but it's basically heartbeats and so on. And then you connect the G-Node B, and the G-Node B uses the NGAP protocol to make a setup of the connection between the RAN and the core network. We will show that in the trace later. And then actually, if you turn on the UE, it will send yeah, I don't know what's the first message, but it will then send a registration request towards AMF, and then the AMF will authenticate using the authentication server function and send it back with the security mode command messages. And then you have the registration basically, and then the UE will request a PDU session. So it will request a data session, and then it will go from the UE over the G-Node B to the AMF, to the SMF, and then actually the SMF will handle the connection on the UPF. So it will do an on the fly for this specific user, the tunnel on the UPF. And that's also the step where we configure all the IP addresses, the tunnel endpoint identifier, and all these kind of things. And the tunnel is then between the G-Node B and the UPF. And so this was the control plane, but then later, like real user traffic is traveling from here to here, here to here then. That's a very basic overview. There is also many detailed flows in the specification, and I think later I will also show you one of these if we have time to do the deep dive. But that's also maybe a good topic for tomorrow to actually really go into the protocol details and see that. Yeah.
For the message exchange, that's what they talk about. Then they will
Yeah.
see what they say to each other and what they set up.
Yeah. All right. Any more questions?
I have a question.
Yeah.
Where are the antennas in this picture? And then you have the radio interface, and I have my phone. There's a base station somewhere. So where is this in the picture?
You know, from the core network perspective, the GNOP is just a box. It's just software.
Yes, but
No, where's the antenna? Like really?
But you know, I can also answer, but I mean, it
No.
would be helpful.
Yeah. I thought this is the antenna. So this is really the place where we have the radio, and it's basically here. And like as Robert has said, we are using this RF SIM, which is basically a local replacement of the radio interface on your laptop. So you exchange information here between the antenna, like the base station, and the UE, the terminal, via your laptop. But again, in the real setup, yeah.
Smartphone
Thank you.
Here, and then you have antenna, and this is basically what is around where you have like the wide antennas and so on. That's the GNOP.
Yeah.
And you can also see the signal.
So that OSM, is that like an image on its own that you basically don't spin up? If you spin up a USB driver, or a USB SDR to access the channel?
That's one for you.
The thing is, so as I said before, so you already downloaded the GNOP image and the UE image, okay? And between these two, this is where you would normally have your radio. So the UE is like a smartphone, like my phone is the UE. And now the only thing is that we will use this RF SIM interface, which is basically a simulated radio frequency interface. So I also got one question individually how it happens. Basically, there are these IQ data samples, so basically the actual signal, but in the digital domain. And then either in RF SIM, you just exchange directly that, and they do all the layer one processing and so on. Or if you then go to some radio with either a USRP or these ORUs with 7.2 split, what happens is that you have here, like the antenna, as we said, with the USRP, they do this digital to analog conversion, and then they send over the air the signal. So, and this is really happening in between here. So maybe I can try to make a picture later. I don't know whether this was the question, whether I answered, but basically the radio information is between, do you see this? Yes, it's between in here. And the GNOB is the same that you would either use for USRP or RF SIM. It's exactly the same thing. What I will try maybe is to set up exactly what we also use here, but with the radio setup, then I will just sort the same containers and you can see it, and then I have a phone, and then maybe we get a little bit more understanding here. But basically what you will run on your machine, the GNOB is exactly the same what you would also need in order to talk to a normal smartphone.
And the RF SIM is packaged in.
Sorry, and now the question, the RF SIM is packaged inside here. So basically also this, normally you would have USRP, and then you initialize the USRP, and then you send something. And if it's RF SIM, then basically you have a TCP tunnel between these two. And typically, but that's not mandatory, I mean, can actually switch, but typically you have on the GNOB side the RF SIM server. So this is basically TCP server, which waits for connections. And on the UE side, you have then the client part, which then connects via TCP to the other side. They just set up a connection, and then they send these IQ data samples that I had. So basically the digital domain of the actual signal that will be sent, and they just exchange really this low level information. And that's it.
Great. Okay, great. Any more questions?
I'm just wondering, if I'm running things like this setup, how to say this should, is it possible to manipulate GPS coordinates of different groups?
That That is a very good idea.
Not sure if I understood the question exactly.
But you mean if you use 5G localization, for example, or
Possible to manipulate the locations of the
So, I mean, yes. So this is something that we can see tomorrow. So basically, the RF SIM does not only exchange these IQ data streams, so this digitized radio signal. The RF SIM also has some functionality to kind of emulate a channel. So it's not a full channel emulation, but you can have something like this, and then you can, for example, set the path loss, and this corresponds to a UE that would be further away, or you can simulate some noise. So you can do these kind of things, but it won't be enough to, for example, really use localization features in 5G and so on. So this is then something where you would actually use a real radio, for example, the USRP or something like this. Yes, so but I mean, for example, as also one example, so I mean, there is all these things with like channel state information and so on that is exchanged between the UE and channel B, and all of this will happen on your machine. And we will use something simple where the UE will not like really send channel state information because the channel B will not ask for it, but we could enable it, and then the UE will like send its measurement reports and all these kind of things. And in the default configuration, the channel, there is no channel emulation between the G0B and the UE, so basically means the channel is perfect. That makes it so. But all of these things we can simulate. I mean, you can only in a limited fashion simulate, because as I said, it's not a full channel emulation, because for that you would then also need to actually model the antennas with the antenna gain, all these kind of things. So we don't do this because we basically really stop before the antenna and we just add noise and so on. But in theory, you can do these kind of things. Yes, so I mean, this is this one thing. I mean, the RF SIM has certain limitations, okay? So basically you can only have, I mean, I said already I have like the server side and the client side, and you can have multiple clients and one server. So what you, for example, cannot really model is two G-Node Bs and multiple UEs, because then you have like an N-to-M relation, right? So you can only have either one G-Node B and multiple UEs, or you can have one UE and multiple servers. And regarding the mobility, yes, you can simulate this to a certain extent. And I mean, this whole thing about mobility is not really included in this training, but this is something that we are currently integrating. So for example, if tomorrow somebody wants to try this, then we can see together like how to install this, how to compile it, how to then just connect one UE to two G-Node Bs, and then manually at least trigger a handover from one G-Node B and so on. So you can do all these kind of things in RF SIM. It has specific limitations, but I mean, you can get relatively fancy if you want. And yes, and I also, one thing that I want to point out, so the RF SIM is not really like a tool to play. It's actually something that most of the developers use, and but which they like, because it makes the whole things way more predictable. If you have radio, then all kind of things can happen, and there are like actually developers in OpenAirInterface who don't even have a radio at home. They always only use this RF SIM and do all their development, all their testing only with that. Okay, and we also use this, for example, in our CI in the testing environment, and the RF SIM is a real tool, and is a good tool. It has also specific features that look like maybe a bug. So for example, if you will run it later, you won't get the full speed that you might get in the 5G system. But this is actually a good thing, because this translates to you can actually stop the entire system and then debug things. So I mean, in the beginning, RF SIM looks a little bit basic, or you're as if you were not really doing the real thing, but you actually get quite close, and it's quite a nice tool to understand and debug and develop and so on. Okay.
All right. Okay, thanks, Robert. I think we will have a lot of time also in the G0B or in the run parts to go through the details. Here we are just like and that's also what Robert said. For example, I don't have a radio at home. I just use this as a development tool because I'm very focused on the core network. So basically for the purpose of now, we will just use that in the container, and we will just, let's say, use the RFSIM as a given and focus more on the core network. And then we can later in the afternoon turn the focus around. Yeah. All right. So one thing I would like to go through with you is how the Docker Compose file looks, because I think that was a bit, yeah, maybe it was a bit magical what happened before, because you actually did not see how the file looks like. So I know some people are familiar with Docker Compose and some are not, so I will just give a very brief overview how we define that. Can you read that well? Also in the back? No. Actually, I don't need to use my fancy IDE for that. But oh, is that better? Yeah. Okay. You know, I'm a big fan of the dark mode, but this one is better. Okay. So basically, I will hide that. So I'm just using this this tool. It's my development tool. So don't care about all the stuff. It's just about this editor in the middle. So basically, this is how this Docker Compose file looks, and we will actually use this Docker Compose file to start the whole core network. And you can ignore that line. But basically, what we are doing is we are defining services. And one service is, for example, MySQL. Another service is the OAI SMF, OAI AMF. But even the GNodeB with the RF simulator is a service, and also the UE is a service. So we just define these services. And these services are basically containers that are running based on the images. And we already pulled the images. So basically how Docker does that, because before we were using Docker Compose pull, it basically has a list of all these services. And you can see here the image. So it knew what to already pull from this file. Yeah. So you can see, I mean, here we just configure the network. Here we'll really configure the network. So you don't have to configure IP addresses. You don't have to configure how things communicate. Basically, you just launch it and that's it. So it's a very, very convenient tool. I will skip the MySQL configuration because that is very, like you can find that in the internet everywhere. It's just MySQL server running. And there was also the question about the IP addresses. So here we actually just define the IP address of the components. Not of the UE then, but we will see that later. Yeah. So here we have MySQL. Then, for example, like the architecture I showed you before, all these components are in here. So we say, for example, OAI UDR, which is the database. And we say that is the this image, and it uses the tag 2024 June, meaning that is a rather new one. So actually we made that just for this workshop, which is like developed from last week. So that's really fresh. So we say use that image, and then we give it some, we don't have to care about that, but basically we just expose some ports, meaning other components should access these ports. And then very important here is the volumes. Because what we are basically saying here is that we have this file, and that is conf/config.yaml. And this file you should put into the container. So there is a mapping between what you have on your local system and then what is inside the container. I know it's a bit confusing, but basically the container is running inside your machine, but behaves like another machine. Like, as I said, it is really a virtual machine light. Yeah. So this is very important because that way you can configure the whole core network. Yeah, we don't care about this time zone. We also don't care about the depends on. That is something we just did. You don't have to care about that. And the IP address. And that's it. That's the whole thing you need to run, for example, UDR. And then you see UDM is rather the same, right? Okay, and you just point to the config. That's it. Same with authentication function, NRF, AMF, SMF, UPF. Yes, and then we have, yeah, here we call it OAI traffic server. So this one is the one we are using then for experiments. And as I said, for this part now, let's just say that is the internet. Here we did some IP magic, but honestly, let's not go into there. We just set up some IP routing. It's not really important for our purposes. Something which is maybe quite interesting here is that Docker is really nice to define your own networks. So we don't need to set up some bridges or make VLAN or whatever, like all these Linux networking features. Docker does that for us. So basically, we just tell it, okay, user network, we call it public net, yeah, with this subnet. So basically, you have a completely different subnet, completely different network running in your host, which is quite isolated from what is running on your host. So that's really nice, and it's very easy to set it up. Because honestly, if you would need to set this up, all the core network on different machines, or even in the cloud, but let's forget about the cloud. Bare metal in different machines, it will be a lot of work to get the routing done, to configure everything correctly. Everything can communicate. You know, with this, it is just one command and that's it. Of course, you have to prepare these files, but we did that for you. So yeah, and yeah, you can see here on the left, or maybe you can't see that. If you're in your OAI workshop repository, you can actually see we are now in the CN part. So here is this Docker Compose file, the one I just showed you. But here we also have the conf. And for example, here in the conf, we have the config.yaml. And this is actually then the configuration of the core network itself. So here you can play around, you can change different values, you can go through the configuration, configure everything. For the time being, I suggest, because we don't have much time for the lunch break, let's leave that file as it is. Let's just accept the default values we have here. If we have time and the interest tomorrow, for example, or later today, to actually really go into the config, change things, we still have time to do that. Yeah. Right now, I would just like to actually tease, because we have 15 minutes, I would just like to actually tease how to actually start that and what is happening. And I know 15 minutes sounds very close to doing that, but I will just very quickly show you that, and then in the afternoon we can really go through step by step. Yeah, because I think that was enough frontal talks. All right, so actually, if you go back to the README, everything is like, and the good thing about this README we provided to you is you can do that on your own. So you actually would not need to do that together with me, but basically you can do that on your own. But let's just do it together once. Or actually, I will do it once so that you know how it works, and then you have time to play around and everything. Yeah. So that's how it looks like. We will ignore the first part because that is also something Docker does for us, because it's actually written or an easier way. So let's do the easier way. So basically, if you're let's do one thing first. Sorry for that. We made a quick update before the break. So actually, to get the newest version of the code, you should do a, yeah, Robert? Yeah. If you want to follow live now, you should do a git pull. And git pull basically tells the git command to get all the newest information and all the newest files we have uploaded. It is like, if you just watch what I'm doing now, it's not important, but it's important later. And it's also important when you're going to use OpenAirInterface in the future to use this command, because we always update the repositories, we push new things, new features, new config files, and so on. So to ensure that you're always up to date, you should use this command. Yeah. All righty. Here? There's a question actually. You don't have to? No. That's a very good question actually. So the question was, if we did the git pull, if we need to build the OAI, no, because basically here for the git pull, we just get the new files, the config files, but we don't have to build the code, and we don't need. It could be that we need new images, but for this change, we don't need new images. Yeah.
Basically, what we see is that we just pulled some updates in these README files where the commands that we have to type are written. So we made some minor updates to take out some bugs, and you just see that we changed these 3 READMEs so that we have just the latest changes. So that's also one reason why we don't need to build anything or no new images. So.
Yeah. All right, but that's just a detail. Thanks, Robert. Yeah, whatever. Okay, so actually, maybe I will just do it for once here, and then later we can really, yeah.
So after pulling it override, whatever you configure for not.
Will it overwrite what you configured?
Whatever you have configured before pulling.
You want to take this one?
Yes, I will answer this one. It's easy to answer.
Yeah, it depends.
Well, it depends, yes, but basically, if you don't make any local modifications, you can just pull and it will overwrite what you had there before. If you, for example, make local modifications in code or documentation or whatever, and it would overwrite something, then it will tell you that it cannot update right now, okay? So, and now, I mean, you see, that's also why I said we just updated the README. So it didn't change anything, any configuration. It didn't, for example, if there was a change in the Docker Compose file, then it might actually have an effect when you try to redeploy. But here it's basically just the documentation. So in this specific case, there is nothing that really changes in the sense of configuration or whatsoever. Okay.
Yeah, you avoided the hot topic of merges. Okay, that is good. All right. So yeah, again, I will just go through the deployment very, very quickly, and then you can digest that over lunch, and then we can do that in more detail in the afternoon. So yeah, basically now we finally can start the core network with Docker Compose. That's why we did all the preparation. And basically, we just say Docker Compose. Right, let's follow the tutorial step by step. So basically, we say Docker Compose up -f. That means we are using this file. -f means file. And -d means it's running in the background, because otherwise it will just print a lot of stuff in the console. And we are actually starting MySQL first, because if we do that, Docker will create all the networks and do all the preparation, so we can actually start Wireshark. I will just copy that. Okay, so that doesn't work anymore. Yeah, we have to update it. So sorry, we will update the tutorial later. There is a mistake in the, because we updated that, yeah. Anyway, so I did the command now, and we see MySQL is running. And you can see here running, and it said network OAI workshop created. And that's basically why we did that. And we have the container MySQL started. So if you can do the docker ps command now, we can see all the services that are running, and at the moment it is only MySQL. But we started that because we wanted to have the network. So if we now start, for example, Wireshark, again, I will go through later, like in a slower pace. That is just now to have a brief overview. If you start Wireshark, we can actually already see what is happening in the network. And that is actually very convenient because we have the network here. And I will enter capture filter. Again, I will go through that later. But basically we can see now live what is happening in the network. And because we only started MySQL, there is no network traffic right now. But if we now do this, if we say, let me go back to them, Docker Compose -f Docker compose. There's no autocomplete. Up -d, and I don't specify MySQL. We will start all the services we have seen before. So actually, with this command, we will start the whole core network and everything. That's a religious war. Let's not go into that. Yeah, so basically you can see, thank you, Robert. You can see we had all these containers now started. So we have OAI NRF, XDN, UDR, UDM, AMF, SMF. So everything I was talking about before, that is now running. And actually, if you do Docker compose, Docker PS, you actually see there is many containers running. And if you zoom out a bit, it looks like that on your machine. If you zoom in, it's a bit unclear. Yeah. All right. So, I mean, that was really easy, but what does that actually mean? That means on our laptop is now a core network running. So the whole OAI core network is now running on my computer again, and everything is ready to connect, for example, a G-Node-B or a connector device. So we really have that here, and that is why we used Wireshark before. We started Wireshark before, so you can actually see these are all the messages that have been exchanged. So that's what is communicating in the core network the whole time. So as I said, at this point there is just many heartbeats and so on. Was everybody able to follow? Maybe not on the console, but to get what we did here. Because I don't want to overwhelm you before the break. So what we could do now is to just start also the G-Node-B and the UE and just watch how it looks like, and then later we can go through and have the setup working on all, like after the lunch break, have the setup working on all your PCs. I think that's the way to do it. So right, so now we have the core network running. So everything is ready. And for example, I said before that we're using NGP protocol to connect the G-Node-B and the UE. Yeah. Okay, so that was all a bit fast. So I think most of you have now the core network running. So if you type Docker PS, you should see many components here. I think most of you have that step already now. And it was very quick how I opened Wireshark and everything. I will just do it again slowly. And so you can actually see what is happening in the network. And then I would say, make a break then. So we can only have a look at the core network now. And then after the break, we connect the G-Node-B UE and do traffic tests and so on. I think that's good. So basically, yeah, now we have the core network running. It is running on your machine, but you don't see much. So that is why we are using this tool Wireshark. So basically we have all installed the tool. So you just need to start it. So I mean, just, yeah, either click here or type the Windows icon, and you just type Wireshark. And that's it. You could even start it in the console, but yeah, let's forget about that. So now you should have this open. Unfortunately, I cannot zoom in here. You should have that. And then you should see a capture here that is called OAI workshop. So you should see that network. Okay, so there is a problem with Wireshark with many of you, most of you actually. So there was an issue with the installation. In our case, there was a problem in adding the Wireshark to the root. Like before, I was telling You have to click somewhere yes. I think many people did not do that. So that's not a problem, but basically that means we have to start Wireshark as a root to see all the images. So basically, please close Wireshark, everybody. And then you go on the terminal and you type sudo Wireshark, like that. So if you have that, again, you have to put in your password and then it will launch. And now you should actually see the interfaces. Okay, hey, just a quick announcement. I see everybody's busy setting it up. We will do a lunch break now until 1 is the plan. So it would be great if people could be back again at 1. And then we will start again, like really from scratch, go through all the things very slowly. Don't worry. We will just go through everything very slowly, Wireshark and everything, and we can set it up together. All right? Great. So enjoy lunch. See you later. Okay, guys, we will soon start. Actually, before we start, it would be great if we could clone the repository of the run right now, and we will just do that in the like in the background, so we can continue with the tutorial. But then for the run part, we will be ready. So if you could just go to your home directory, yeah, here, and you just clone this repository. I also send it to you via email in the morning, but then again, I think I took the SSH one. So if you could just clone this one right now, that would be great. Sorry, I will go back. No.
I think you didn't send it.
I didn't send it?
Not working? I got Git, right?
Do I have to do the .git?
No.
Yeah, normally yes, no?
No, it's okay.
It works? Same. Great, thanks. Oh yeah. Okay. Oh yeah, there's a redirect. So yeah, that should actually work. Okay, people, we are going to continue with the core network part now. Don't worry too much about the clone of this OpenAirInterface repo. Anyway, the servers are down now, I think, or will be very soon. It was just for preparation. We can also do that later. So if somebody finished the download, that's great. If not, then it's not a problem, right? So we will do that in the run part maybe later tomorrow, or yeah. So good. So actually, I would like to continue where we left off this morning. So just to again start the core network and see what is happening in the Wireshark, and just make an attachment of the G0B and the UE. And then we are quite far already. And then maybe later we will show the same demo, but with the real radio in the back. Yeah, but I will just go through the steps with you again so that you understand what's happening, and then we replace the RF simulator with the radio. Great. Okay, so let's go again into our repository, which was open now. Sorry, which was OAI workshops. Actually, let me, yeah. So then you have to go to the core network, and basically, yeah, if you want to start the core network, maybe let's do something else. Maybe let's stop the core network, because probably on some of your machines that is still running. So please go into that directory and type docker compose down. Yeah, you see it was still running in my my setup. So please just type that docker compose down. That will actually remove, it will stop the core network and it will remove everything it created. And then also, sorry, I should stick to one Docker. And if you did that, you also should do, sorry. Oh, no. Okay, actually, no, that worked. I didn't actually start it, but yeah, it's important so that first of all you do docker compose -f docker compose .yaml down, and then you do minus like that. Both of that you should do if you started the core network and the radio. Just to make a clean state now, and we will start from the beginning again. So yeah, I will start from the beginning. Now we destroyed everything. So basically you just say docker compose -f docker compose YAML app. And this again will start our core network. And in the tutorial, yeah, here, in the tutorial, we basically have the first step saying here that we should start the MySQL first. We can do that, but actually it is not very important. It is just when you want to trace, okay. I think I have to speak louder now, the microphone. Yeah, doesn't like me anymore. Anyway, so this MySQL is not really important. It is just when you want to trace from the start. But in our case, let's just skip that and let's just directly start the core network. So it is basically, let me zoom in here as well. So yeah, it is basically just this command, and you type it, and you could actually see, like again in the tutorial we have the command -d, meaning it is running in the background. You can do that, or you can do it the same like I did without -d, and you actually see a lot of logs, what is happening in the network functions. So whatever you prefer, to be honest. Yeah. So now we got the core network running. We see that. So we see they're printing some log outputs. I encourage you to follow that a bit, read what is happening there. But it's also important to do this docker ps to check that is actually running. Yeah. Yes. And then you can go in another window and you open Wireshark. And for many of you, the Wireshark did not work the installation correctly. So please just use sudo Wireshark. So you do that, you type your name, and it is coming. So now, and this is important, not at the moment, but later when we start the RF simulator is sending a lot of signals back and forth. So if it just starts the Wireshark trace, it will overload our computer very fast. So it will overload the RAM and your computer will crash or will slow down. So to really avoid that, in our tutorial, we have this so-called capture filter. And this capture filter tells Wireshark only capture, only put these filters into the output. Sorry, only these protocols, these ports, these IP addresses, whatever. And we prepared this capture filter for you, and you can just use that one. So that one is in the tutorial, and you should just copy this string here. Yeah. So you copy that one. Actually, and for the guys who are using the remote over the Mac, this command here is basically Wireshark on the console. So this tells you start Wireshark. It's called T-Shark, which is the console part of Wireshark. -I OAI workshop, that is the interface, and -F is the capture filter, and then it's an output file. So you could use the one which is written here, which is like temp OAI workshop, or whatever you prefer. So call it capture OAI workshop, and then you have it on your machine, like on your host, remote host, and then you can just download it via, for example, SCP, and then you can watch it on your screen. But it won't be live, so that's the only disadvantage. But I think it's easier than doing the forwarding. I don't know, did you try that with this Edge thing, Edge Wireshark, or yeah, no, never mind. Just do it that way. Do the capture, and then later you have to stop it, you have to download it, and then. All right, but for all the others who have the local setup, it is easier to just start Wireshark and do the live capture. Okay, so yeah, basically. So again, please just copy this filter, and then you go into Wireshark, and you will see something called OAI workshop here. It's very small, but it's called OAI workshop. And here above, where it says using this filter, you just paste the filter. That's it. And then you just, then you just double click on this OAI workshop, and the Wireshark trace is running. So you can actually see all these messages here exchanged are no messages which are core network messages. Did everybody? Yeah. Okay, I will. All right. So all of us have this view now. So basically, you can see what is happening in the core network. So all these messages in the core network. The way it is now, it is a bit not very good to see, but actually we will filter later. But what we can see now is that we have everything between the core network, all the signaling, all the information between that. And for example, I will just show you some examples. Because if we go back to our architecture, so I told you in the morning about the NRF, which is like this repository function. And how that works is that all the components are talking with these repository functions via HTTP REST interfaces. So basically, you can actually see that now, because if you filter HTTP2, which is the traffic here, you can actually see a lot of these. I don't know how familiar you are with the HTTP protocol. I won't go into detail, but basically this is all REST interfaces. So the interfaces you see in all the web applications, like whenever you have front and back end, it's these kind of interfaces. In the core network, we use the same principle. So you can see here a lot of these exchanges, for example, between the different components and always to the NRF, this patch command. And that basically is used as a heartbeat, meaning all those components, they're telling the NRF, I am still here. I'm still here, I'm still here. This is my address. You can reach me via my address. And they don't really put anything else. So because we didn't connect any device or so, that is basically all we have for this part. Then we also have some TCP traffic here that is mostly between the UDR and the MySQL database. We don't have to go into that here. And then also very interesting is the PFCP protocol. And PFCP is a short for Packet Forwarding Control Protocol, and that is the protocol between SMF and UPF. So basically, this is the protocol that controls the UPF, tells the UPF how to route user traffic, right? So, and again, because we didn't connect any devices, now it's just a core network running, we just see heartbeat. So we can see heartbeat request, heartbeat response, and so on. Unfortunately, I cannot zoom in here, I think. I can. Control plus, great. Maybe this is better to read. Would you like, should I go through a bit how this Wireshark looks like, or is that kind of clear for everybody? Because maybe it makes sense to just have a quick overview, because basically out of this you have the packet number that's like just linear increasing. You have the time when the packet was exchanged, and what is really important here is the source and destination. So you have source IP address, destination IP address, then the protocol, and then the name, the title of the message. And here you can actually see what is being exchanged here. So here you can actually see the content of the protocol. And right now that's not very interesting, it's just a heartbeat, but later, like now when we connect the devices, it's very interesting. So if we're good so far, I would say that it is time to connect the G node B. So for that, I am using the packet filter SCTP, because I know that all the traffic between G node B and core network is using the SCTP protocol. Now you should go back to the terminal, and if you follow the tutorial here, you know, we are here deploying OAI core network. We did that. That actually works. And yeah, you can check these messages. This is what I just explained, and also the heartbeat between SMF and UPF. And now it is part to deploy the G node B. And that is actually a very good thing what we're doing here, and we will follow that because it's really interesting to see the logs of the component. And yeah, so just go into a new terminal and type this: docker logs OAI AMF -F. And then you just press, and then you open another terminal and you do the same. Sorry, you don't do the same. You say SMF, not AMF, because these are the two components which are part of the session establishment. Right, so now you should have some terminals. And by the way, with right click, new tab, you can make this tabbing. Yes? Okay. I think now we are ready to, does everybody have the log output and everything is running? Because now we will connect the G node B. And for connecting the G node B, we will use this command. We will say docker compose -F docker compose run.yaml up OAI G node B. And again, we could use -D, then it's running in the background, or we don't. In that case, we are using -D because the G node B prints a lot of logs, and actually we don't. We care about that, but we care about that in the next workshop and not in this one. So it's easier to just do -D, just to have a console. So I will do that. Oh yeah. You should always make sure to be in the right directory. What? Again, the YAML with A and YAML without A thing. So I did a typo here. Anyway, so now I just launched this command. And now the G-Node B is launched. And it will give you a warning. First of all, something like this is deprecated, so you don't have to care about that. And also the other warning about the orphan containers, like OAI, UPF, SMF, you can just ignore that, because that basically means that there is some containers which are not managed in that file, but just ignore that. But what we did now is we started the OAI G-Node B. And if we go back to our trace, to the Wireshark, we can actually see there was something happening. So we have this SCTP connection setup, which is not very interesting, but what is interesting here is to have the NGAP setup request. So with this, you can actually see that the G-Node B is connected to the core network, because we have the setup and the response. And if you go to the OAI AMF, you will actually see the G-Node B information here. So you will see the G-Node B is connected now to the core network. Are you following this, or? So this one is now the logs of the AMF. So I would just go around and see how we're doing. Because the next step is actually connecting the UV and all right, guys. So I think everybody got the G-Node B connected. So everybody should see that in the Wireshark. And actually, if we go to the AMF logs here, you can actually see this table, and you should have this status connected. And you again, you should see the G-Node B RF thing. So that's the status where everybody in the room should be at the moment. So what we're doing now is to connect the UE. Basically, now the goal is to connect the device, and then we do some traffic tests for this device. And to connect the device, I see some of you already did that, but I would just also go through that. Basically, you just copy this command without the minus, please. I think we did not update that. Anyway, so just yeah, that was not smart. Because we have the GitLab update at the moment at this time in France, and I had it in a cache and I don't have it anymore. But it doesn't matter because you also have it locally. So I think all of you have it here. So you can just open this file also in your terminal, or you can open it in an editor. So you have it here, and yeah, and you can copy the command from here. It's not as convenient, but still. Yeah, anyway, so basically just type this command, docker compose -f, docker compose run YAML up -d OAI NRUE. And if you have that, you should get your device connected. So it's basically the same command as before with the G-Node B, but instead of typing OAI G-Node B, you type OAI NRUE, obviously. Okay. So what we have here now, for example, if we look at the AMF, you should see that now. You have the G-Node B connected, but now you also have UEs connected. So you should have this UE, and the state should be 5GMM registered. And you have the IMSI, you have like all this information. But basically, that means your device is connected. So it's like end-to-end, all connection work. And you can also have a look at the SMF logs. They're a bit more verbose, but you can actually see there's a lot of stuff happening here. Yeah. And if we now go into the trace, into the Wireshark, we can actually, if we go down, we can actually now see what is happening here. So we see there is a registration request from the UE to the core network, and authentication request, and all this kind of stuff. I was talking about in the morning. So are we there? Right, you are. Yeah. Yeah. Okay. Yeah, I think that just means in the trace in the Wireshark that is connected. But what you actually should do is, again, if you follow the workshop data, is to get the IP address of the device. So basically, you can just say docker exec, and that means you execute in the container, and then you say OAI nrue if config. And if config just shows you your IP addresses. And when you have this interface, it means you're connected. So everybody should see this when they type this command. Right? So I got a very interesting question. I think that's interesting for everybody. Basically, now we are all connected with the UE. And just to show you a bit what is happening here and what these messages mean, I will just do a filter for these two protocols. So basically NGP or PFCP. And I will just very quickly, really very quickly go through which components are involved here. So we see the first message here, and that is the registration request. And you can see this IP address is from the UE. No, actually, this is the IP address of the G.B, but it's coming via the UE to the G.B, and this IP address 132 is the IP address of the AMF. So that's G.B to AMF. And also we should include HTTP2 traffic here, but let's not make it too complicated. So for example, here the UE is sending authentication request. You see? No, sorry. Yeah, registration request. So there is a registration request, and then the AMF 132 is asking the authentication server function to authenticate this UE. So that's this HTTP request. And then the authentication server function asks other components, but that's going too much into the detail. But it gets all the informations, and then it tells the UE, okay, authentication request. Please authenticate towards the network. And then the UE says, okay, authentication response, so that you can actually verify that the key in the SIM card is the same as the key in the UDR. And that's why we have all the authentication going on. Very, very high level. So there's much happening here. But that basically means the UE is authenticated, and you have actually this 5G AKA confirmation. And that's one of the procedures happening here. So there's again a lot of chatter between the network functions. Then we have the security mode command where they just confirm the security parameters, again between AMF and UE via the G.B always. And in the end, we have some other things, and I think it's better if the RAN people talk about that. But what is happening then, which is really interesting here, is actually this message. So after what we did now is registration, authentication, security, exchange of all the parameters. And now what the UE is sending is this so-called PDU session establishment. Because so far, all the communication, I don't have this, wait. Yeah, luckily I have it locally. So everything happened now between this, the UE, the G.B, AMF, and these three components. So basically, let's call them database subscriber management components. But the SMF and the UPF so far were not involved at all. But now it comes to the session management and PDU session establishment. So now it's basically only SMF and UPF. So we can actually see here, again, UE sends it to AMF, but then AMF is sending it to SMF. And in the meantime, that's maybe also quite interesting. What is happening here is that AMF is asking the NRF, is there an SMF around? And that is just this discovery procedure. It's just a detail, but this is the way we ensure that this is cloud native, because we don't have a pre-configured. Basically, it all goes with this discovery mechanism. Anyway, but that's just a side note. What is interesting is actually this message here, because that is communication from AMF to SMF, where the AMF is telling the SMF, okay, I have got a PDU session establishment request from the device. And then SMF is handling this and is then actually selecting a UPF. So there's much going on in the SMF at this point, and it basically selects one UPF. And here it could select the UPF based on slicing information, based on DNNs, based on resource utilization. We didn't implement that, but also based on policy. So there's many things how the SMF could select it. But at this point, it's just very, very simple, just based on slice and DNN. And it actually selects the UPF. And then it communicates to the UPF via the PFCP protocol. So again, wrong. So again, now it's from here to here to here, and then to SMF, and SMF and UPF communicate. And that way we can actually create a tunnel then between the UPF and the GNOT ping. I won't go into the detail of the protocols, but just that you know an overview what is happening here. And then SMF is replying to AMF, okay, everything worked. They exchange the tunnel IDs. And actually, to answer the question regarding the IP address, let's have a quick look into that. Yeah. So this is now very much to the message details, but just because that was a question in the morning, actually you can see the IP address of the user equipment here. So basically, SMF now tells the UE, I've given you the IP address 10.0.0.2, and the UE has to use this IP address, and that's this kind of IP allocation mechanism. So that's it, and then we have some back and forth also between the core network and the UE again, but at this time, the session is established. So we actually have user traffic. And now we can actually verify that. So if we go back to our training material, I will just open a local just an editor because I don't have the browser at the moment. Give me a second. README. So yeah, so this is now the same tutorial. I just have a local editor for that. So now we have the IP address, and now actually we want to do a traffic test. And for that, actually, we just go into the UE. So we execute this command. It's docker exec -it OAI nrue bash, and that just means that we kind of like SSH into the Docker container. And now we can, for example, do traffic tests. So again, I'm always going wrong. So when we are in there, for example, we cannot ping 888, I've heard, because there is some firewall rules here. But for example, we can ping a component. We can ping a component in the core network, because this 192.168.70.1 through 5 is actually the traffic generator, the one we were talking about, which is the internet. So if I do that, you can see the ping is working. And that means that is going through all the tunnel information. And I stopped the capture, but if I just filter for ICMP, which is the ping, you can actually see that the ping is happening here. Okay, actually it's a bit weird because we don't see the GTP tunnel here. But yeah, anyway, so at this point we have established a connection and the UE has access to the internet. And that is basically the goal of the workshop here. Because from now on, this is just doing optional things. We could, for example, connect another UE, and then we can have a very deep dive into the logs and the pickup. and do advanced traffic tests and everything. But I think for now, that is enough to show how to launch the core network, how to launch a UE. I will go a bit through the crowd and see how it looks like, but I would actually conclude this part and then make a short break, and then we can maybe have a look how the demo is going. Right.